to the Road to Resilience, Chaos Engineering, Game Days, and Disaster Recovery. I'm really excited to be here with you all today. When we talk, reliability is no accident. And if there's anything that we've learned over the years, we've learned that reliability takes work and a plan and strategy and a lot of tactical actions, which include that teamwork and collaboration. And so I want to talk about how you can make your systems more reliable and how everyone can work together to improve reliability. So I want to take a look really quick if anybody remembers this AWS outage that happened really recently, what this really meant for customers. If you look at this outage and the impact that it had, this 5-hour outage was huge and it impacted so many organizations. And at the end of the day, failures are inherent to complex systems. And that's really important to understand when we talk about reliability because our systems are complex. And if you think that you can get away with maybe choosing a different cloud provider, you really can't because there's large outages that have happened at Google Cloud. There's outages that have happened at Microsoft. There's also outages that have happened at Salesforce. So outages happen, incidents happen. So what we want to talk about is how we can be prepared from those, how we can look at these, and how we can understand the potential downstream effects that happen from these outages and incidents. Because as an SRE, as someone in DevOps, when something happens, you want to figure out how to prevent it from occurring next week too. And that's why we talk about chaos engineering, because it's a great way to think through that in a systematic, logical, and team way so that you don't have to do this by yourself. You can practice chaos engineering with coworkers and you can learn from each other. However, you probably would like to know who I am. So as mentioned, I'm Julie Gunderson. I'm a senior reliability advocate here at Gremlin. You can find me at Julie_Gund on Twitter. You can also reach out to me via email at julie@gremlin.com. Prior to joining Gremlin, I was a DevOps advocate at PagerDuty. So I focused a lot on incident response, mean time to recovery. And so working with chaos engineering just makes a lot of sense. So one of the things that I want to talk about today is a great resource. So if you haven't checked out this book, Accelerate, it's amazing. Accelerate was written by Dr. Nicole Forsgren, who's a PhD and responsible for the Dora report, Gene Kim, who wrote the Phoenix Project, and Jez Humble, who is an SRE over at Google. This is an amazing resource. They've done a great job of collecting all of the research that they've gathered from practicing DevOps over the years, and also creating the DevOps survey and report that Puppet would send out. What they did is they took 4 years of research and they came together to analyze that data in a great way and to bubble it up and say, what are the most important things that you need to do to create a high-performing technology organization? And in Accelerate, they focus a lot on tempo and stability. And a lot of the time folks ask, well, how do you measure chaos engineering? How do you make sure that you're doing the right thing when you're doing this type of work? How do you improve that the work that you did actually makes a difference and is able to move the needle, especially if you have a lot of different people doing different projects? And it's really important to be able to measure back and say, this is the work we did. This is how it moved the needle. And this is the ROI that we got from that work. Now, over the years, a lot of research has been conducted and books have been written as to how to improve the resilience of our software. So for today, I want to deep dive into the 2 key practices that improve the key measures of tempo and stability outlined in the book Accelerate. Now, the key practices are chaos engineering, game days, and disaster recovery. Today, I really want to talk mainly about chaos engineering and game days so that you can learn some practical tips to put into action that focus on resource consumption, capacity planning, and large-scale outages. So first, let's talk about what is tempo and stability. So tempo is measured by deployment frequency and change lead time, and stability is measured by mean time to recover, so MTTR and change failure rate. And if you break that down even further, Deployment frequency would be the rate that software is deployed to production of like an app store, for example. So within a range of multiple times a day to maybe a really long deployment frequency, like once a year. And tempo would be the change lead time. So the time it takes from a customer making a request to that feature being built and rolled out to where the customer can use it. So the time it takes from the request to the request being satisfied. And then stability is our mean time to recover. It's the mean time it takes a company to recover from downtime of their software. And stability change failure rate is the likelihood of defect changes. So if you roll out 5 changes, how many of those will have a defect? How many of those might you need to roll back or might you need to apply a patch for? Is it 1 out of 5 or 2 out of 5? So those are the type of metrics that Accelerate recommends that you measure. And so back to key practices. Now, as I mentioned, there are 3 key practices here: chaos engineering, game days, and disaster recovery. And I'm going to focus on chaos engineering and game days. So according to Accelerate, you should focus on improving reliability because it's the foundation that enables you to have a really great tempo. It enables you to improve developer velocity, which makes so much sense. But what's really nice, as I mentioned, is they're backing this up with data of 4 years of research. And we know that engineers feel confident when software is reliable and they feel more confident to write new code and confident that their features are going to work well. And they understand the different failure modes because they've been focusing on reliability and have been in trying to improve reliability, which actually makes you able to ship code faster and more reliably. And it's really exciting when you can ship new features that work and that you can trust will meet requirements. And in Accelerate, they say that we should build systems that are designed to be deployed easily and can detect and tolerate failures and can have various components of the system updated independently. And this is a lot of different things that are really great to work towards. So right now, I just want to focus on detecting and tolerating failures specifically. So what's the best way to know if your system can detect and tolerate failures? Chaos engineering. That is one of the best ways to purposefully inject real failure and see how your system can handle that. So what I want to show you is a real demo so that you can see what it looks like. So this is a really cool open source project that you can find on the Google Cloud Platform GitHub webpage. And it's a repo called the Bank of Anthos. So definitely check it out. This is the architecture diagram, and it's great for learning how to practice chaos engineering because it's an internet banking application that has multiple languages. So both Python and Java, which is pretty common these days, when you're working on the system, there are oftentimes those multiple languages. Then we have the 2 databases. So we have an accounts database and a ledger database, which are running on Postgres. And then we have our transaction history service, a balance reader service, a ledger writer, a contacts user service, and our front end and a load generator. So this is what it looks like. Now, one of the questions we would want to ask ourselves when we're starting to practice chaos engineering is, what is our hypothesis? We want to think through what's going to happen if we do a certain thing. So for example, does black holing a critical path service like the balance reader result in a graceful degradation of the customer experience? So you want to think through this. If we make that balance reader unavailable, so we make it unreachable, which is what black holing is, that's a gremlin specific attack. If we make that unavailable, what will occur to the application? So you want to think through these ideas. You want to think through what will happen. Will we be able to use the website? Will we be able to see what the balance is? Will we be able to deposit funds? These are the questions we want to ask ourselves. We also want to think about what kind of error message will we get? Will it be a user-friendly message? We're going to hope that we would get some sort of loading, that there was a type of issue with the balance reader that was no longer available. Or maybe our system was just built really well and we could fail over automatically. So let's go ahead and see what would happen. So I'm showing you within the Gremlin application, but you can do this with any of your chaos engineering tools. Let's select the balance reader service, and we're selecting it as a Kubernetes replica set. And we can learn a lot here because we can see that only one pod is impacted. So if there were multiple pods, then we'd actually see that there are 2 pods impacted. So this shows us already when we're running our chaos engineering experiment that when we make this balance reader unavailable, we're making it all unavailable because there's no secondary pod. And this is what it looks like when we run our experiment. The balance reader will appear as dash, dash, dash. And think about this. This could be really confusing to the user. If I was building this as a real internet banking app for a bank, they'd be like, no way. We're going to get so many support tickets if this really happens, because that's not even a real error message. And then that makes that user confused, and they might start calling the call center, which increases the cost and the time of having to answer all those calls. But we also want to check out other functionality too. How does this affect other dependencies? So the user is still able to make a deposit of $1,000 while the balance reader service is in that black hole, because you can see it in the transaction history that we've added money to our account, but the balance is still dash, dash, dash. But if we try to make a payment, we're unable to do that. And then we get this engineer-friendly error message, not a generally friendly customer-facing message. I mean, when you think about your friends and your family who don't work in tech and they see this, are they going to pick up the phone and call you and say, hey, I don't know what this means? Because I can tell you that my mom calls me every time there's something wrong with Facebook or Hulu or rarely Netflix to see if I can figure out what's wrong, even though I repeatedly tell her that I do not work at those companies. But this is something really good to think through. What kind of errors are you showing your customers? Do they make sense? And that's what we want to look at, is that customer experience of reliability. So that should also be part of your hypothesis. Now, as we go through this, another interesting thing to look at is the different types of failure modes. So let's have a look at the transaction history service and see how a black hole might affect that. And this is the transaction history here, and you can see what it looks like when things are good, and you can see the debits and the credits and who made the transaction. But what we want to see is, will we get a graceful degradation if we make this unavailable or not? And during our experiment, we can see that the transaction history is not there. We get an error that says could not load transactions, but we can also see that our deposit was successful. So this is better than the dash, dash, dash that we got with the balance reader. And it's also not talking about get, so it's a much more user-friendly experience. So how can we mitigate against these tags? So these are things that you want to think about. So you can look at how can we scale our Kubernetes. So you can actually use the command kubectl scale deployment transaction history and give it 2 replicas instead of just 1. Because if you remember, there was only 1 pod in the last experiment that I showed you. And we'll do this for the transaction history for this example. So run the command, and now we can see in terminal, we can see kubectl get pods, and yep, we have 2 pods running in our transaction history that'll be able to show us the data. So now what we can do is we can go back and rerun our experiment. And this time we can run it with a smaller blast radius. So instead of sending all of the pods, because there was only 1, into the black hole, we'll send 50%. And then we can see what will happen now. What's our hypothesis? We're only sending 1 of the pods into the black hole. Are things going to be okay? Are they going to get worse? And it's interesting because you're never going to know until you actually do the experiment. So we really want to visualize what's happening. And we now have those 2 replicas. And so this could be a very, very short outage, not even visible to the human eye, because that other pod is going to take over. That's what you're doing when you're testing this with chaos engineering. You're walking through these scenarios. Now we can see that we didn't get an error message, and the user is actually able to get all of their data. So we've been able to validate our hypothesis and also affix and mitigate a potential issue. So you can actually find this all at the Google Cloud Platform Bank of Anthos. The other key practice that I wanted to mention quickly was game days. So game days are a really great team building exercise, and something that they talk about in the book Accelerate. They will help you improve stability and reliability, but they're also going to help you with your culture. So an example of a game day is you just want to have 2 or more teams and invite 4 or more people to attend. And you work on a failure, and then you can understand how it appears to the other team and how their failure may appear to you. Other Examples of game days are dependency testing, capacity planning, and auto scaling. And so with that, I just wanted to let you know that there are ways that you can build the reliability of your systems through chaos engineering and through game days. You can also look at disaster recovery. And if you're interested, we do have some free certifications at gremlin.com/certification. And I just wanted to thank you all for being here.